Okay, so today we're diving into something pretty mind-blowing. And, yeah, it's quantum computing.
Ooh.
But specifically, how it's going to completely, revolutionize cybersecurity.
Okay, yeah, have you heard a little bit about that?
I've heard a little bit about this, yeah.
Yeah, so we're going to be using some excerpts from this text we have on quantum computing.
Okay.
Cryptography and communication, all that.
Yeah, it's all connected, isn't it?
It really is.
Yeah.
So I think it's going to be a really interesting deep dive.
Yeah, this will be good.
It's like, you hear about quantum computers and they're going to like change the world and stuff.
Right.
But the cybersecurity aspect of it is just crazy.
Yeah, it is.
Because it's like a double-edged sword.
Yeah, it's a double-edged sword. Yeah.
It can be used to like really protect us, but then also it can completely destroy
everything.
Destroy everything.
Yeah, no, it's kidding.
Like it can break all the codes we use.
Yeah.
Essentially, yeah.
Yeah, and there's this thing called Shor's algorithm.
Right, Shor's algorithm. Yeah.
Which, that was something that really stuck out to me in this text.
Yeah, it's a big one.
Yeah.
It's a big one.
Because it can crack the codes that protect, everything we do online.
Well, yeah, I mean, theoretically it can.
Like our banking, shopping, emails, all of it.
Yeah, all of it.
So how does this Shor's algorithm actually work?
Okay, so Shor's algorithm is specifically designed to tackle integer factorization.
Okay.
Which I know that sounds...
a little technical.
A little technical, a little jargony, yeah.
Yeah.
But it's the foundation of a lot of the public key cryptography systems, like RSA, for instance, that we rely on today to keep our stuff safe.
So what is integer factorization? What is that?
So imagine a lock.
Okay.
And the only way to open that lock is with a very specific key. And that key is based on the product of two really, really big prime numbers.
Okay.
Those prime numbers are your secret ingredients. Mm-hmm. And a traditional computer would take forever to try to figure out what those two prime numbers are.
Okay.
Just based on the product.
Just based on the lock.
Just based on the lock. Yeah, exactly.
Gotcha.
But a quantum computer running Shor's algorithm could do it way faster.
Like how much faster are we talking?
Exponentially faster.
Oh, wow.
So it's not even like a competition.
It's not even competition.
Right. So are all of our secrets online about to just be like...
Well, not quite yet. Okay. Because while quantum computers are advancing, they're not at the point yet where they're powerful enough to actually run Shor's algorithm on the scale.
Got it.
That we need to break all the encryption.
So it's not happening yet.
Not yet.
But it could.
Okay,
so are people working on this? Yeah, so that's where post-quantum cryptography comes in, or PQC.
PQC, okay.
Yeah, and it's this whole field of research where people are trying to develop new encryption methods that can withstand both classical and quantum computers. Mm-hmm. It's a race against time, Yeah,
because, we got to make sure that...
I can make sure it's ready.
It's ready before quantum computers get to that point.
Exactly, yeah.
Wow.
Yeah.
So... that's scary, but quantum technology can also be used to enhance security.
Right.
Exactly.
Yeah. And there's this thing called quantum key distribution.
QKD?
QKD, yeah.
Yeah.
And it sounds like it's...
very sci-fi.
It sounds like science fiction.
It does, doesn't it?
Yeah.
It's really cool, though.
So basically it uses quantum mechanics.
Yes.
To create, unbreakable codes.
Well, essentially, yeah.
Yeah. And, any attempt to, spy on the key exchange would just, break it.
It disrupts it, yeah.
Yeah.
It disrupts. And that's how you know that someone's trying to...
Exactly.
Yeah, it's like a built-in alarm system.
So how does that work?
Okay, so it's all about quantum states.
Okay.
So think about this.
Okay.
You have information in a QKD system, and it's encoded in a quantum particle.
Oh, okay.
Let's just say a photon.
Okay.
And quantum mechanics says... that just looking at that particle...
Observing it,
yeah, changes its state.
Oh, wow.
So if somebody's trying to intercept the photons that are carrying the key, they will inevitably change them.
Right.
And introduce errors that both the sender and the receiver can detect.
So it's like a self-destructing message?
Kind of, yeah.
Wow.
Yeah, it's pretty wild.
That's really cool.
It is, yeah.
So does that mean we could have truly unbreakable codes?
In theory, yes.
In theory, okay. But
the big but is transmitting this quantum information over long distances.
Oh, okay.
Even with fiber optic cables, the quantum states degrade.
over long distances.
So even quantum cryptography has its limits.
For now, yeah.
Okay.
But researchers are looking into solutions for that.
Oh, okay, like what?
Like, for example, quantum repeaters.
Okay.
Which would be like a booster for quantum signals.
Okay.
So you could extend the range of quantum communication.
Oh, wow.
So it's still early. But imagine like a global quantum network. Yeah. That would just change everything.
Be crazy.
It would, yeah. It would revolutionize not just cybersecurity, but also fields like distributed quantum computing, quantum sensing.
Wow, it's really like we're on this precipice of a new era.
Yeah, it's exciting.
Yeah.
It's a little bit scary.
Yeah, it is a little scary.
But it's mostly exciting, I think. Yeah.
It really does feel like the laws of physics are going to like reshape how we communicate.
How we live our lives, basically.
Yeah, basically.
Yeah.
So as we continue to explore this, the key is going to be to
proceed with caution, I think.
Yeah.
Yeah, and make sure that like security and ethical considerations are
at the forefront.
At the forefront.
Right.
Yeah.
Because we don't want this to go wrong.
No, definitely not.
So to wrap things up, think about this.
Okay.
Will we actually be able to navigate this whole quantum landscape?
Right.
And use it for good?
Right.
Or will we always be like one step behind?
Yeah, it's the
people who want to exploit it.
It's a big question. Yeah, it is.
So that's something to think about.
Food for thought.
Yeah.
Definitely.
It's pretty wild.
It is wild, yeah.
All right, well, thanks for joining me on this deep dive.
Thanks for having me.
This is fun.
Yeah, this is good.
All right, we'll see you next time.
See ya.